Hello, I'm Spencer Hanson, and I researched how to build an operating system from scratch. So, what is an operating system? Well, an operating system is the software that displays everything you see on the screen, and it communicates with the kernel. And the kernel is the thing that talks with the hardware of your computer so that the operating system can actually do stuff with the physical hardware. For example, if you want to access a file on your computer, first you would open up a file browser to access the file. The operating system would bring up an interface, which would ask the kernel to read the physical hard disk, and the kernel would then display the data on the interface. So what is Linux? Linux is an operating system just like Windows or Mac, except that it's open source, which means that anybody can modify it, and it'll get upgraded faster, and it'll have better security patches, except that it's not very user-friendly, which means that it uses a lot of terminal commands and a lot of programming, so that it kind of scares a little bit people off so that they don't use it as much. Linux was created in 1991 by Linus Torvald as a college project, and he developed the kernel, and it was a merge of the commonly used operating system Unix and the open source project GNU, GNU, and GNU was a software project made specifically for open source software for Unix, which makes Linux a very open source operating system. So SOS, or Shadow Operating System, is the operating system I developed. I built it from scratch, compiling the Linux kernel and many packages, which I customized, rewrote, and modified. I created SOS for a smaller operating system size, better, faster speeds, and faster security patches so that I could customize it myself. I am in control of all the customizations of the system, and there is no wait for a software patch to fix security bugs. To create SOS, I use some freely variable materials. First, I use VirtualBox, which is virtual machine software that it lets you run an operating system inside of another computer so that you can reboot and reload the operating system without actually having to restart your entire computer. And I used the Linux from scratch live CD, which a live CD is an image file that I can boot into through the virtual machine so that it'll reset every single time I restart the operating system, so I can build my operating system through that system. There's also the Linux from scratch script, which is the script that I use to download all the packages and that compiles them and verifies them. I began my basic build setup by setting up the hard disk on the basic Linux machine, and I partitioned the hard drive into 4 different partitions. First partition was the system partition, where the Linux system that I was creating would actually be built. The second partition is the /user space, which is basically the space for all the shared files for all the users and configurations. And the third is for the swap space, and the swap space is the space for, it's like RAM, except it's on a hard disk, so that it can, if you have low memory on your computer, it can use hard drive space as RAM instead. And then the fourth partition is for the files to actually build the operating system, so that's where I developed it in. So after successfully installing the system to the hard drive, I began to modify the software packages, add different features, and change different settings. And I also can recompile the kernel and add different kernel modules. So some of the examples of the packages I modified are Nano, which is a lightweight binary and text editor, wget, which is a web file retrieval tool, the X-Window system, which is a very primitive GUI, and a GUI is a graphical user interface, which is usually what you see when you boot up Windows or Mac. It's the images and stuff. Otherwise, it would just be a console. And DHCP-CD, which is Internet Access Control, so that you can access the Internet and go online. And Lynx, which is an in-text web browser. Oh, and SSH, which is secure shell, and you're allowed to remotely log in and control the computer from somewhere else. I also added support for users so that the users have the basic file system set up, and I modified the shell system so that they have special customizations, and the shell is formatted differently. a custom login message, which is displayed after it boots, a manual compression script so that all the manual files for all the programs on the computer are compressed down to save disk space, and a static random number pool for the kernel. And the static random number pool is every time you restart your computer, it keeps this random number pool so that you don't get the same random number every time you restart, and that other programs that use the random function don't generate the same number, so it's more random than it would actually be. The Linux standard base system, which is just a compliance protocol that says that my system will give you the details about how and what it does when it works. And Windows file system support, which is very useful if you want to access any Windows file disks, because Linux uses a different file system than Windows, and if you want to access a Windows file system on a Linux system, you have to have some support for that. And then miscellaneous partitioning tools to resize and reformat the hard drive. So now I'll show the actual OS and all of the systems I used. So this is VirtualBox, and this is the virtual machine software, and it boots up, and this is the little operating system inside of the computer. Up here is the virtual machine that contains the live CD. I can either boot off the live system, which is its first option, or I can boot from the first hard disk, which is where I installed my system. Now it loads the bootloader, which is basically it gives me an option to boot either from the operating system or to boot from the recovery mode so I can recover files. And so right now it's booting into the kernel and setting up all of the things that it needs to run. And it's just booting up right now. But once it finishes, it'll display a login screen with the customized message like this. And I can log in as root, and I have a customized terminal. And I can show you some different commands that I installed, such as like the DHCP-CD, which is the internet connection. So if I can type ping Google, it's reaching Google, which means it has internet connection. Also, there's Nano, which is the text editor I talked about. And you can type stuff in here like that. There's OpenSSL, which is an encryption protocol for the system network, so that when you connect to different websites and stuff, it uses secure connection, and these are all the different secure protocols that it has on the system. There's also the X-Window system, which is that very primitive GUI, and I'll start up the X server, and it has a mouse and a basic terminal and a console with mouse. And there are two other packages I installed. One's called GPM, and that's it uses software to incorporate the mouse pointer into the console, and Links, which is the in-text web browser I was talking about. So if I type Links and hit G, I can go to google.com. And then I can search things by clicking on the search bar and get results. So that's the in-text web browser. Now, I also have some network tools that I've installed too. So, okay, so during my presentation, or during my making my operating system, there's a lot of compiling time because I had to compile the code for 5 hours at a time. So I have a bunch of experience in programming, and I made some apps before for iPhone and Android. And so I made a game for just a simple game, and I'm going to show that to you. If you come up, Martin. So it starts out, and there are two blocks. Yeah, and you just move around like this, and you try to cut the enemy player off. And what you can do is you can also speed up, so you can go faster to give yourself an advantage, and then win or lose, depending on what happens. Oh, looks like you lost. Okay. So. Okay, so I'd like to acknowledge some people. Karen Physick, who was my research advisor and helped me write my paper. Lori Ball, who organized my project and set up meetings with the IT people. Spencer Gajapathy, who was my mentor and helped me through my project. My parents, who sponsored me to be here. And Excel Energy, who was my research sponsor.